Thank you for joining us from where you're joining. Like always, we have an exciting call today, and we have our guest today is a colleague in my team, Marcus Carvalho. He is a senior PM in our team. Me and him work in the application and developer advocacy and awareness team. Uh, like always, we have something called, we do something on apps, APIs, SDKs, something to do with developers, DevOps. Today's topic is get your apps ready for zero trust. So some ground rules. We're going to record this call and put it in our YouTube channel, ak.ms/m365pnp/videos. You can follow us on Twitter at Microsoft 365 Dev, where you would see a lot of announcements of similar calls, as well as on Azure AD. You can follow me on LinkedIn at Nandeesh Swami. And we do this community call every third Thursday of the month, right? Like we have our next call coming up on March 16th. So let's be respectful. If you have any questions, feel free to put it in the chat. We'll be happy to take it up. And we should be good to go. Yeah, so we will be sharing out surveys through the call. We would love to get your feedback on how the call is going on and how the series is going on in general. This really helps us put things into perspective. Now it's time to hand it over to my dear colleague, Marcus.
Thank you, Nandeesh. So I changed my shirt because Nandeesh told me earlier today that I need to show off my microphone so I can look like Joe Hogan with a lot of hair. So I did it. Right. So quick introduction. So I'm Marcus. As Nandeesh said, I'm in the same team as him. So I work in the application and development CXP team. So one of the things we do is learn new things. So we learn things every day, and we try to share these things with people. And we like to solve problems. And by solving problems, this is something that we're going to talk about. So we're going to talk about how applications can benefit from zero trust, or how can you get into zero trust. So we start with an introduction. So you won't see any live demo. So some of you may have joined the workshop we had earlier today that I was doing live demos with the risk of failing all the time. So this one will be recorded because of the complexity of the demos you will see. But everything is shared, so you can use source code and look into everything that will happen. Let's start with zero trust. So understand what the definition that Microsoft gives to zero trust. Actually, we may even update that slide because saying Microsoft definition of zero trust is probably not exactly Microsoft. So if you look everywhere, you see more or less the same thing as over and over. So there are three pillars for zero trust. One is verify explicitly. So verify every connection, every request. Make sure that everything is the service is working. It should be the data is exactly the way that the data that you can access. So make sure that every time you need access to the data, check that or authenticate and authorize everything. So other one, use least privileged access. So always require the minimal permission for that action, and assume breach. So you don't know where the resources is coming or the access is coming from. So make sure that you understand that so that you can verify, use least privilege, and understand what are the actions that you need to do to minimize the radius of the attacks or connections. So the key thing for one of these principles is conditional access, right? So conditional access is the pillar of the essential feature we have that to cover the never trust, always verify premise. So with conditional access, we will look into different signs from every connection, and every time a user tries to get an access token or identify themselves, we will validate the request against this rules or policies and define what you can do with that. So we will allow access, we can enforce MFA, we can limit access, make the access, because that connection is a bit different, so let's reduce the amount, reduce the surface, or the basic stuff, block access. So we can do much more than just, okay, block access, don't access anymore. Okay, go home, don't do anything, you're blocked. So we can do more. So we can enforce MFA today. We can even use something called authentication strings, where we can define what authentication method that we can use to get access to an application. So one of the key things, and that's where we're going. So our focus is more on the application and how the application would work with conditional access, never trust, always verify. So the first thing that we're going to do is understand how applications authenticate with Azure AD or any identity provider. So everything that we do is based on authentication standards, on open standards. So we use SAML, WSFed, WS Trust, OpenID Connect, WALS2. So all protocols are just standard, open standards and available to everyone. We have different client application types. So we have web-based applications, and that is key to what we're going to see next. So we have applications that will run server side, so applications that run on the server. So things that ASP.NET, these applications where the code runs on the server and that just renders a UI, so a web browser UI that you can play in a browser and then send data back. So Java does that too. There is some flavors of Node.js doing that, but these are becoming less and less popular. So the most popular model that we see today is single-page applications where JavaScript runs on the browser. So the browser is intelligent. The browser runs the code and connects to a backend API. So the browser is actually running everything. So everything runs on the client, nothing on the server, or the browser just calls an API to get data and then renders the UI itself. It doesn't require a server to render the UI. Another type of application that we have is actually native apps. So native apps can run on Windows, Mac, or iOS, Android, doesn't matter. Can even be a console device, can be something that doesn't have a UI, just have like a text interface that you can't type. So these applications, they will have different ways of logging in. So the whole user authentication surface in Azure AD is web-based. So you will render a UI, and that UI will be in a browser-like window. So that browser-like window can be system browser, or the browser that is already running on the OS that we share the surface. Could be an embedded web view that is actually locked into your application. So it's just on that universe. It doesn't share anything outside your app. Or some applications do that, can be a custom logo screen. Not something we do with Azure AD, not something we recommend, because that will actually allow other things to do. So it's the kind of thing that you type a username and a password, and then you authenticate to an application. So if you do that, you will lose everything that we offered in terms of security, in Azure AD of authentication methods, passwordless, and these things. And the console apps that I mentioned, or devices that are headless, that don't have like a browser or UI, there's an authorization flow called device code flow. That device code flow will actually just show a code in the headless device. It can be just a text interface, and you can go on your phone or on your PC and authenticate that externally, right? So this is something that we can also do. So you don't, even if that's something, an IoT device that doesn't have a UI, you just show a code, and then you can use that code to authenticate. So Microsoft facilitates all of this using MSAL. Although remember, we're talking about open standards, so you're not bound to our libraries, but we have some flexibility, some things that you will see as we go through that are unique to the library. Some things that you can do with any library. So MSAL, or Microsoft Authentication Library, is the library that we develop and is running. They're all open source. We have versions for the vast majority of popular platforms, at least they are all there. So .NET, JavaScript, Java, Python, Android, iOS, a bunch of other things. So let's look into how the authentication pattern is. So when you're writing an application, you actually try to authenticate your app. So you authenticate against Azure AD, and you basically do two things. Because of the way the protocol works, so OpenID Connect and WALS2, there's a concept of refresh token and tokens, and we need to validate. I mean, sometimes or many times, the user doesn't need to interact with the server to get a token. So that's the first. So the pattern is you always try to get a token silently. Try whatever method you have to get an access token. So we can usually, so MSAL will search first for valid access tokens that it already has. So it's still on the cache that they are valid. So if this doesn't exist, we'll try to use a refresh token. So all of this doesn't require any user interaction unless something goes wrong. If that fails, so if user interaction is required, we fall back. So that's the way we work with the pattern. So we catch the error. So UI required exception, that's the standard MSAL exception that Azure AD sends and MSAL translates, knowing that the user needs to interface. And then we do what we call acquire token interactively. So then we will show the browser window, the user will authenticate, and then we'll move on, right? So that's the process. You always try to get a token silently. If something fails, we fall back into the UI. So that is important because every time you try to acquire a token, conditional access will come to play. And if something changes, remember, never trust, always verify. If something goes wrong and it doesn't work anymore, conditional access will not allow it to get the token. And that's when the error comes, and then you need to fix something to get a new token. So the silent token will not work. So that's why this pattern is important. It doesn't require to be MSAL. The vast majority of libraries will do something like that. So this is basically the standard authentication pattern for the protocol. So the key thing about zero trust is that today you can't just rely on IP addresses or that the users are running the application from inside your network. You don't know where they're coming from. So you don't know if they really are who they say they are. So that's where the device comes to play. Device has a very, very important role when it comes to authentication and authorization. So there are a bunch of things you need to know. There are three concepts in terms of device. And to be honest, we at Microsoft, we mess up with these names and create a lot of confusion, but I'll try to set up or to make the logic on how these things work. So we have one scenario that we call hybrid joined device. A hybrid joined device is a device that lives in two worlds. It lives on the on-premises worlds as part of the Active Directory on-premises, and it also lives in the cloud. So it's also a machine that it's known to Azure AD. Right. So that scenario actually is a variation of the on-premises one. At the end of the day, the machine is joined on-premises, is just extended to Azure AD, and Azure AD knows about that machine. So a hybrid joined device for Azure AD, we know that that device exists on both worlds, and you can even consider that you have some sort of on-premises management or control on that device. This is one point of trust. So the other scenario is what we call Azure AD joined device or cloud joined device. So these are the names that you hear us using. So a cloud joined device or Azure AD joined device lives only in the cloud. It doesn't know on-premises AD, so it's not part of the directory, but it doesn't mean that it can't access on-premises resources. That's a common mistake. A lot of people think that an Azure AD joined device cannot access Carvalho stuff. It does. That's not the context of our call. I'm not entering into the details here, but the important thing is that a cloud joined device is a device that lives in the cloud. So AD on-premises doesn't know about that device. The other scenario we have is more common with mobile devices. That's what we call a registered device or a workplace joined device. That was also the status for Windows 8, Windows 7. They also had this workplace joined thing. So a workplace joined device is a non-managed device, right? It's a device that is known to Azure AD, but there's no management rule yet on it. Azure AD just knows about the device. It doesn't know what it does, right? Or doesn't know where it came from. Someone registered that device, and that device is known. So if you try to access an application using that known device, Azure AD knows about it, and then we can create rules based on that. So all of these scenarios, they don't mean, at any point, they mean that your device is compliant with any rules, right? We just know that the device exists. We can use other things about it, but we don't know if they have an antivirus. We don't know if you're following your own policies. That's where the MDM comes, right? So when an MDM comes, or a mobile device manager, like Intune, doesn't need to be Intune, but when you have an MDM enabled, so that will actually use the device register in Azure AD or the information that we have in Azure AD to notify Azure AD the status of the device. So the MDM, if it's not Intune, there are integrations with Intune that will allow that to do. Not not getting into how it works. We can do follow-ups on that. But the idea is that Intune is the API that any MDM will use to tell Azure AD that the device is compliant. And we can use that in a rule later. An MDM managed device will be what we call a managed device or an enrolled device. Okay, so these are the terms that we use everywhere. So the idea here is to show you how these things show up for you, or how you may see in the documentation, and understand what is the status of the object. So a hybrid join device, an Azure AD join device, or a registered device, they are not managed. We just know what these devices are. The other thing about that is that is the key information, because if you don't know what the device is, you can say it's compliant. You can say that device is supposed to be accessing your application, right? So that is the basis of everything that we're going to talk in this session. So what we do, what conditional access can offer in terms of device. So this is the old stuff. So in the past, Azure AD was only able to say via conditional access, oh, is the device compliant or is the device hybrid joined? Only these two rules. This is the past, so you should not use that anymore. We introduced it some time ago, what we call device filtering, where you can use this and much more. So you can use, so think about, now we know about the device. If you know about the device, we can use any attributes from this device to create rules based on that. So you can create rules from manufacturers. You can create rules from the operating system that they're running, the version of the operating system. You can use trust type. So, oh, is it hybrid joined? Is it registered? Is it cloud joined? So you can use that there. You can check if the device is compliant. So is compliant is just an attribute there. So you say, oh, if you want to create a rule that says that the device is compliant, you just create a device filter and use that. You can use extension attributes. Imagine that you have kiosks that you want to control the access. So you can use one of the extension attributes and say, set an attribute saying this is a kiosk device, or this is a shared device. You can use that, or it's a dedicated workstation. You can use these attributes to extend the conditional access rules. Right. So this is very powerful. And the key thing for your application, in terms of your application, is being able to tell that story to Azure AD, tell this device status to Azure AD, so that Azure AD can apply the rules. And if it doesn't work, you see what happened during the demo. Another important concept you need to know, mobile application management, or MAM. MAM is, in our case, in the case of Azure AD, is actually applied by Intune and is not protecting the device, is protecting the application itself. MAM requires the device to be registered, but doesn't require the device to be managed. Right, so we need to know the devices too, but we don't need to manage the device. So if you look into that, you can protect the application, like enforcing a PIN, controlling the sharing of data between applications, enabling, you enable application via the Intune SDK. So this is nothing, this is a completely different story, right? You need to download the Intune SDK, implement the Intune SDK on your app. This is only available for iOS and Android. So that's an important thing. The device doesn't need to be enrolled in Intune or MEM. There is a catch, by the way, on Android to use MAM. It requires you to install the company portal, but that's about libraries. So you don't need to register. You don't need to use the company portal at all, but you need the application installed because of the libraries, right? So it's don't get confused in terms of, oh, you need to register or you connect to Intune. That's not the case. You just need the application sitting there. You just put the application on the mobile device and should be it. You don't need anything anymore. And when you're using MAM, conditional access works on a different way. So there are two other options that you can apply, right? So there are two options that you can use. So there's one that's called required approved client, and another one is required app protection policy. When you use require approved client, that is actually a fixed list of applications. There is a list of applications that is in the article there that will tell you what are the applications that are approved clients. That is not great because it just means that the application can use MAM, but it doesn't mean that the application has any policy, is enforcing anything. So think about that. This is like the Outlooks, the Teams, or the Words, so the Office applications. So they are all in the approved client list. But if you check that box and use that box, you will not protect, you're not protecting the app. You just know that the app is capable of being protected. So that's why we have the second option. So the second option requires not only the app to be approved, but can also be applied to any application, even the ones you develop, as soon as they have a policy applied. So the Intune manager goes there, creates an application policy, assign that policy to your application, and whenever you open that application will receive a policy. So that status actually inside Azure AD, we can actually check. Okay, you're connecting from an app that is protected, so has the Intune SDK, and downloaded a policy and enforced a policy. So it has, I'm sure that it has a PIN, it has, I know, it's blocking copy and paste and stuff like that. There is a catch. The UI is misleading. So if you look into the UI, you see the two checkboxes are selected, and the option down there says require one of the selected controls. That's actually not really true. As soon as you select require app protection policy, any approved client app will require a policy, right? So if you use the first option alone, good. If you check the second box, it doesn't matter what the application is. The applications that you developed or Microsoft applications, or the approved list is not only Microsoft, but the approved list, everyone needs to have a policy. So if you don't have a policy, even if it's Word or if it's Outlook, they will be blocked, right? So you need to apply a policy. But that's kind of a side thing. So a lot of developers look into the Intune SDK to protect the application without needing to protect the device or being so invasive and trying to control the device of the user. That is the approach in that case. Much more complex to implement on compared to the things we're going to talk about today. So now let's start the demo part. So it's not like it's like a big demo. I'm showing you, the goal here is to show you everything that happens in each one of the scenarios. So every time we have something, what in a scenario, what will happen? So what is the structure? So what are you going to see? There is a conditional access policy in place. That conditional access policy is actually protecting our cloud applications for selected users. So only the user that is running the demo. So there is a device filter that excludes registered or joined applications. So that kind of policy is not recommended, it's just for demo purposes. We're actually just showing, okay, if the device is registered, if Azure AD knows about that, or if it is domain joined, we will allow them to access. Otherwise, we will block access. So in other words, we're saying that only registered devices for selected users can access my applications. So that's it. What about the devices you will see in the demos? So there is an iOS device. That iOS device is registered. So that device is registered using Microsoft Authenticator app, right? So inside Authenticator, the device registered to Azure AD. Android, same thing, registered to Authenticator app. So registration can happen using the Intune company portal, but that's not the case. The device that we're working here doesn't have the company portal. It's only registered, so it's the basic setup. And on Windows, we have a Windows device that is Azure AD joined, no hybrid. So it's just connected. It's a Windows device that you log on with a cloud account, perfectly fine, corporate device that can be managed by Intune or not. That's not the case here. So it's just joined. So before we move on, there is one exception to the rule because of one of the demos. The iOS device is actually enrolled to Intune or so you understand why later, but it's related to the Apple SSO plugin. So as we move on, you understand the reason. But it's a decision you need to make when you're creating or working with your apps. So let's start with the first scenario. So we have a web-based app, right? So it's a browser app, and that browser app doesn't have anything special. You're doing MSAL, you're doing a public library, doesn't require anything Microsoft. You're just running a browser application, JavaScript, standard stuff, right? So what happens with these applications when they start to run on the devices? So the first device we're going to look is Safari. So Safari on iOS, you have this browser app. Remember our conditional access policy. The device tries to connect to the application and gets access blocked, right? So you see that this is the screen that the user will see if they're trying to to access your application straight away. So that will not work. So for your application, your web browser application to work, you require something called the Microsoft Enterprise SSO plugin for iOS. Right? So this is part of the Microsoft Authenticator app. Remember, we installed a Microsoft Authenticator app for the device registration. That feature actually is based on the Apple Extensible Frame and Enterprise SSO. It's something that Apple developed. And we just configure that on the iOS device. And by configuring this plugin, we will allow single sign-on. So we will recognize the device and the device will be compliant. Okay? That is a catch. So the only way to push that configuration into a device is by using an MDM, right? So you need an MDM, doesn't need to be in tune, but you need something that will push that config or that configuration, tell what is your domain, what's your tenant. So tell that configuration to your device so that when Safari opens, Safari is compatible to the Apple Enterprise SSO. And because that plugin is already configured, you will be able to perform SSO to your application. So in terms of application development, nothing is required. It's an admin thing. So the administrator will actually need to set up to manage the device and ship the Enterprise SSO plugin into iOS. What about Chrome? Chrome is similar, so same, but the user experience is different. So when you try to access an application that is protected, that requires device authentication in Chrome, that's the first screen is the one that you're going to see. So there will be, it's a misleading screen. So it will actually tells you, oh, you need to a certificate to move on, but there's no certificate. So you can't choose anything. So that is the catch with Chrome. Chrome, there's something in Chrome called enable browser access. So in Chrome, you need to click on a button. That button is available needs to be done manually. It's available on Authenticator app and also in the company portal. You just go there after your device is registered. You click on a button, and that button installs the certificate you see on the second screenshot, right? So now you have the device certificate, and unfortunately, that's the user experience in Chrome. So the user tries to sign in, it pops up, select the certificate, you click on allow, and then you can connect to the application. If I'm not mistaken, that only happens once. After you did the first time, it stores that information and doesn't require again, but at least the first time, the user will see the prompt for choosing the certificate, even if you only have one. Right? Unfortunately, that's how it works. What about Edge? So Edge will work on every interface. So Edge works everywhere. So it doesn't matter. So if you're trying to use Edge on Android or on iOS, and there's a small difference, is just that on Android, it will force you to register the device, to sign in before you use Edge, if that happens. On iOS, you can browse anonymously and then you can sign in, but it's just like a user experience. The sign in will happen. After you sign in, everything is fine. The device information is sent to Azure AD and your application will work. What about Windows 10? So Windows 10 is a bit different. So Windows 10 has native support on Edge, right? So if you're using Edge, we'll connect straight away. Remember the scenario? Our machine is cloud joined. So because it's cloud joined, Edge is capable of understanding, of interacting with the OS and doing what needs to be done. And Edge does single sign-on with device information. Everything is fine. If you're using other browsers, so Firefox enabled that support after version 91. So if you're using Firefox in a recent version, that will just work. Chrome requires an extension. So you need to install the Windows 10 accounts extension from Chrome Web Store. If you're an administrator, you can ship that via DPO. There's a registry key that Chrome uses to install extensions. The link there will give you the hints on how to do that. After you install the Chrome extension, it will work just like Edge and Firefox. So we'll just sign in to any application the way it's supposed to do. So these are the web scenarios. So from the developer perspective, there's nothing to do. Is more on an administrative scenario. So, but you are as a developer, you need to understand the impacts of your choice, right? So if you're dealing with an administrator, if you're building an application to a company that's using conditional access and reinforcing devices, you need to know what will happen and what to tell to the administrator that they need to do. Chrome is a quite common scenario, right? So you create an app, your app works on Edge, and then someone calls you and say, well, but I'm trying Chrome and Chrome is not working. Well, you need to know that you need to install the extension on Chrome so that Chrome can do single sign-on and share the information of the device with Azure AD, right? So that's the idea of this section. The next section of this webinar is more focused on the native clients. So this is where the developer has choices. So in here, you will understand what you need to do to make your application work correct. So the first thing you need to know is about embedded web UI. So embedded web UIs are locked into your application. So they are not shared within the device. Let's run these videos and you see the user experience. So the user tries to authenticate. This is the sample app that we're using. We will choose to use embedded browser. So you will see on the screen switch. So the screen is the same. So you didn't leave the application, right? The whole screen is your application. But now if you try to log in from there, it will fail, right? Because embedded web UI cannot access or cannot share the device information. So that's exactly what will happen. You try to connect to your application and the access will be blocked. Remember the pattern that we talked in the beginning? You try silently fails, you fall back into UI. That's exactly what happened here. So we try, remember our device is registered, we do single sign-on. So we try to log in, it failed, and then we get back. So you don't see the screen switch. You will see the difference now when we go to the system web UI. So if your application is selecting to use the system browser, not an embedded browser. And by the way, this application is using MSAL, and in MSAL you can choose which one to use. The default is system web, right? So the default is the one that works. It's not the one that doesn't work. But works, but we need to be careful. I'll just run the video and keep on talking about what's happening here. So we're going to use the system browser. You will see the application switch, right? So that's the user experience. You see the switch. Now you're seeing the browser opening. So you're not on your application anymore. And you try to access the application and it fails, right? Why it fails? Because the browser is the browser that you saw in the previous section of the webinar. So if the browser is not configured correctly, your application will also fail. So what we need to do for an application that is running on iOS that uses the system browser to work, remember, Enterprise SSO plugin. Without the plugin, your app will not work. What needs to happen on Android? You need to click on that button, enable browser access. If you don't enable the browser access, your browser cannot authenticate. So your application cannot also authenticate too, right? So now we rely on the browser. That's why we started with the browser. So if you understand how the browser works, you understand why your app is not working. And that's painful. Let's keep on going. There's two more scenarios before we fix everything. So this is Windows UWP. UWP is a pity because it doesn't use system browser at all. So you can't use system browser with UWPs. You're limited to use embedded web UI. And guess what? You already know about the browser saying about how browsers work, what you expect that will happen here. It will not work. So you see everything. That's already bad news because the application already asked it for a username. Remember, this is a domain joined machine, though you should have single sign-on. So the fact that it required a user authentication was bad news. Now it's doing the whole passwordless authentication scenario. Passwordless will work. So you will authenticate to the user authenticates, you see, authentication passed, bang. You cannot do anything, cannot access this right now. So that message is because we're using the embedded web UI, and we know now that the embedded web browser cannot talk about device information. So that application will not work, right? Or not on this way. So nothing that you saw here to now is a dead end. So there is a solution we'll talk about in a minute. So now I'm telling you everything that doesn't work so that you can choose correctly and understand why the app doesn't work. Quite common, so that's where I started talking about. So quite common with Windows developers. So if you have an application that is created on premises, so this is not a UWP, this is a regular Windows application. A regular Windows application can perform what we know as Windows, integrated Windows application, Kerberos and TLM, this kind of things. So although you will have single sign-on, so the application will actually authenticate. So you will say that you can select integrated application, we can click on login, but that will actually fail because integrated Windows authentication is purely on premises. Right? It doesn't use Azure AD. So what happens? Remember the pattern from MSAL uses? Try silent. IWA is actually a silent method, so it doesn't need a UI. It tries silent, it fails, a UI interaction required, and then when you go to the interactive logon, it shows you the browser. So that application works, I can tell you. So if I disable the conditional access policy, it will do single sign-on. But whenever the conditional access policy that requires device information is started, your access is blocked. So your single sign-on will not work. So it will be we need something else, right? So I hope it's very clear to you what happens in the standard scenarios. So all of this is a standard. It doesn't require exactly MSAL as a library. So that could work with any library that just supports the browser. What we're going to talk about is something that is more specific to MSAL. Something we have to fix all of this, and we'll give the best user experience compared with any other thing you already saw. So we have the concept of what we call authentication brokers. So brokers are actually an application that will run on your device, or a model. Let's call it a model. A model that runs on your device, and that model will take care of the authentication part. So your application will actually relay the request, the authentication request, to that model, or in the browser to the broker, let's say this way, and the broker will do the authentication for you. The application will receive back whatever it's needed. So on iOS, the broker is part of Authenticator. So you install Authenticator, remember, you register your device, you get a broker. So the broker knows about the device, and that will just work. Just a difference in terms of the way the operating system works. In iOS, the broker actually returns the access token and the refresh token to the app. On Android, we have two brokers, and that's also leading to confusion. It's the same broker, but it can be installed via the Authenticator app or via the company portal. You don't need both. One of them is good enough. Whoever installed first will be the active broker. So if you install Authenticator app and then you install the company portal, the broker in use will be the Authenticator one. So if you install on the other way around, so if you install company portal first, you will see and then after you install Authenticator app, the broker in use will be the company portal. That is tricky because sometimes you want to look into the Authenticator app and you don't see any user account, but that's because the broker in use is the company portal. And the company portal doesn't need to be logged in, by the way. You don't need to register on the company portal. Just install the company portal, we'll install the broker. And then the device can be registered and do everything. So you don't even need to sign into the company portal. You just need to install it, and that will do it. Difference on the OS infrastructure, on the OS implementation. In Android, you only have the access token. I should have triggered the video so you see how is the user experience. There you go. So the application you select to use the broker, you click on login, you see the application switch, but now the application switch is on Authenticator, right? So you don't switch to the browser anymore, you switch to Authenticator, you do the whole Authenticator settings, security settings, you will be able to authenticate. So you see that we didn't type password, that was single sign-on with device authentication. We went just to the broker to select the account, so we could perform single sign-on. So straightforward, the user sees the switch, but it's pretty quick. What about Windows? So Windows also has a broker, so nothing is lost on Windows. So Windows has something, Windows doesn't need an application, so it's built in. So the broker on Windows is called Web Account Manager, or WAM. WAM is part of the operating system, and for any cloud joined device or hybrid joined device, they are actually using WAM automatically. So that's why the browser, when we're talking about browsers on Windows, just work it, because the browser relies on the WAM. So when you open the browser and then you try to log on to your application, WAM comes to play and then authenticates the device. So tells Azure AD about your device, and then you can do single sign-on and use your device information. So everything works. So how do we use that in your application? We need to use MSAL or implement WAM directly. Will be a bit more difficult, but everything is baked up in MSAL. You just select WAM, click on a button, the best experience compared to anything else. You saw, just click on a button, the access token is there. So there's nothing to do. So you just say use the broker. Obviously you need to configure redirect URLs, but we have all the documentation for that. It's not the purpose of the call here, but it's just to show you that that is possible. So it's the easiest, the best user experience. So we have there a Windows application, Windows native application that would also work for embedded, for everything. If you just choose to use the broker, by the way, the code is the same on all platforms. So it's just an option called use broker. And that will actually do, you don't need to change the code if you're using iOS, Android, or Windows. There's one platform missing, that is macOS. For macOS, we don't have a demo, but let's just walk through it and explain how it works. macOS is a bit different from everything that we talked about so far. macOS doesn't have a broker, right? So there's no broker for that. But we do have the same enterprise SSO plugin that we have for iOS. We do have on macOS, but this is actually installed via the Intune Company portal, right? So you install Intune Company portal on your macOS. You log in the company portal, in the Intune Company portal, and that will register the device. The problem is that will actually not make everything work. So because of the Enterprise SSO plugin, you need to configure that via MDM. You will need to enroll the device. It's not only about device registration. Obviously, we have a partnership with Jamf. Jamf can push that through Intune, so that will also work. So Intune, Jamf, just configure. They can configure the company portal, configure the Enterprise SSO plugin, and your application will be able to do everything as it should, right? But that needs to be done via MDM. So without an MDM, let's say, it should not work. Should not, because I'll show something on the next slide. So with macOS, there's one important thing. Because there's no broker, you can't do single sign-on. But the fact that you use the company portal to register the device, not enroll, will actually install the device certificate into keychain. And applications will be able to use device authentication by using keychain. So the user may see the prompt, the keychain prompt, because we want to read a certificate, and that will work. Right? There is a catch. We are working in moving forward and not making that possible anymore. And you will need to use the Enterprise SSO plugin, because registration doesn't mean much. It's just like we're accessing, we don't know much about your device. So that will actually change in the future. So beware that this may work, but you should not rely on that going forward. So try to fall back into the Enterprise SSO plugin. That's the way to go. All right, so with that, we actually reached kind of the end of the session. So quick summary, authentication endpoint will send back HTML and JavaScript. Right, so it will control the interaction. The browser will render the UI into the browser itself for the web control. That's what you saw in all demos. And advantages that we do have for that. So password never stored by the application. You'll be able to use passwordless methods. All the redirections for devices and everything will run. You have full support for conditional access. Users can change password when they are expired, so that web experience can change the UI. You have branding, you can change the logo, images, even the layout with the new features we just released. So you can change the whole CSS for the login page. Users can do all the consent experience through the web UI. So if consent is required, it will not block your application from work, and fully supports B2B accounts. One of the demos, it was a bit quick, but one of the demos that you saw was actually using a guest account. Right, so this is a table, you get the deck. So this is a summary from everything that we tested. So what scenarios work, what doesn't work in each one of the things that you saw. You can check that table later without any problem. And if you want to try yourself, these two applications that we're running on the demo, they are available on GitHub. So you can just take it, configure, and use it. So you can try it on your own, run your demos, test conditional access on all scenarios. You can choose which method to use, and then just make sure that the application works. With that, we're going to use our last minutes for questions, right?
Yes.
It's a lot of content. I tried to make it as fast as I could.
Yes. There were some questions on the chat, and I see Kyle has answered, and as well as Mukesh. So another request, please go to this link and fill in the survey for us. This really helps us gauge the current sessions and plan out the upcoming sessions. We have recorded this video, as you can see. It's going to be put into the YouTube channel, aka.ms/m365pnp/videos. go ahead and subscribe. You can follow me on LinkedIn at Nandeesh Swami to get updates on latest calls, events, hackathons that we do on Identity Platform. Our next call is going to be on March 16th, same time. We are designing and planning something cool and interesting. Stay tuned. As always, you can just follow up if you have any questions offline as well. Here is my email ID. You can just send out an email, and happy to loop in with Marcus or any other experts that are required based on your question. Thanks a lot for joining, everyone. See you in the next one. Have a good time, weekend.
Thanks, everyone.
Bye.